Huh? Good morning. Today we are going to cover this single phase inverter experiment, which is of our power devices and circuit subject. Here basically the operating principle of single phase inverter is related to conversion of DC signal into control AC signal, because here we are using all the power devices. So naturally the output we want controlled AC and the input is DC, which is fixed. Okay. Then after for conduction of this experiment, okay, what is the process? You must have one circuit which is called as power circuit, and the second circuit is called as control circuit. Control circuit will control the power circuit, and thereby you will get the controlled output in the power circuit. Okay, control circuit will be used for controlling the power circuit so that you will get controlled output power. So as the experiment is having this objective, what is the objective? What is the objective? To convert DC signal, fixed DC signal into controlled AC signal. Correct? So for that, how to design the power circuit now? So for designing of a power circuit, you must have 4 switches. So because this is single phase. So if it is 3 phase, then you need 6 switches. If it is single phase inverter, then you need 4 switches, because we are using bridge, 4 switches separately. Okay, so in bridge there are 4 arms. So in 4 arms we can have 4 switches like this. Okay, so now to this bridge, okay, from top side and bottom side we are giving the supply. That supply is called as DC supply, and that supply here it is, you can see here, this supply is how much? 30 volt, which is mentioned here in the multimeter. Just show this meter now. It is showing 30 volt. Okay, 30 volt, which is DC signal. You may observe the same signal on CRO also, because this CRO is power scope. Okay, so the same signal you may observe like this, that this is the DC and this is the positive signal. So the change in the signal, see the reference level is 0 here. Now you can have how much it is shifted above. So it is shifted, you can put it on 10 like this. Okay, now you can see 1, 2, 3, 3 into 10. That means 30 volt like this. So CRO is also showing 30 volt DC, whereas multimeter is also showing 30 volt DC. So you can have measurement by both the multimeter also as well as CRO also, power scope also. So power scope will show you 30 volt signal here. Okay. So you may have observation of waveform, you may have observation of the readings, and you may have observation of the circuit also. So everything you are going to do at a time. Okay, while writing all the readings, you have to take care about all the 3 things. Okay, so in power electronics experimentation, you have to have this type of practice, that what type of power circuit is there, what type of control circuit is there, and then what waveforms are generated and how the readings are we can take. So these things are very, very important for each and every experiment. Okay, so that care everyone has to take. So let us come to power circuit now. So see the design of power circuit here. How it is there? See the design of power circuit. Here this is the power circuit, this much part. Okay, and then all other part, this part is totally of control circuit. Okay, so as we are using 4 switches here, switches are semiconductor switches. It may be IGBT or it may be MOSFET, but as MOSFET is having high switching speed, so people are going for MOSFET in the inverter instead of IGBT. But in some cases IGBT based inverters are also there. Correct na?
Yes.
So you have to think on this direction. Now see here, how many signals we required here, how many gate pulses we required here? 1, 2, 3 and 4. Okay, so 4 switches are there. So control circuit is generating 4 gate signals, gate pulses. Okay.
Yes.
Now this is your supply. Supply is given to the bridge, and in between the bridge, in between means across the bridge, in between you can connect the load. It may be any AC load, bulb also, it may be resistance also, it may be fan also, something like that. Anyway, anything. Okay, so that load is called as AC load. You can connect any AC load. So here they have connected load, which is resistance, maybe bulb, maybe like that. Okay, maybe any resistance also. Okay, so across this load you will get AC. So naturally this yellow and blue, okay, these two terminals, these two test points will give you load voltage, and that will be your AC
AC
voltage.
voltage.
Correct?
Yes.
So right now, internally, all these gate signals are connected to this MOSFET.
MOSFET.
Okay, to this bridge internally. So no need to connect any external connection. Okay, kit itself is having this facility. Only these points are given for testing this thing, to measure or to test like this. So test signals are there. Similarly, likewise, you should have your test signals in your projects also. Maybe mini project, maybe major project, maybe hobby project, but test signals are very, very important. So these points are important in that case also. Now let us come to reading part. Okay, reading part. Now how to take the reading? What is the process for taking the reading? What is the process for taking the reading? What is the process? Part now. Okay. Let us see the reading part. Here what we will do now, already we have taken reading of this thing, that is input DC voltage. Now let us come for the output AC, controlled AC now. So how to see this control AC now? So for that we are having this power scope. Okay. So in this power scope you may observe like this, that this is the black terminal, this is the red terminal. That means this is, we have to connect this side, okay, or any side, because AC is having bidirectional. So we may connect like this also, anyway. Okay. So I am connecting in this way. And then you have to connect the button of this power scope AC. It should be on AC now, like this, because it is having DC and AC, okay, switches. So we have connected to AC. Now this is output AC. Your input is fixed, output is AC. So now you may vary the AC signal. So if you see the process of this experiment, see when DC signal will pass through S1, and then it will go through the load. The direction is likewise, I will say left to right, like this, current direction through the load, and then it will go to the S2 switch, and then it will go to the ground, like this. In other case, second case, when these two signals are given for S3 and S4, at that time current will flow through this S3, and current will flow through the load in a reverse direction, from right to left side. That means negative current, okay, and then it will go through this S4 switch to the ground, like this. So likewise the circuit will complete, and you will get positive half cycle also and negative half cycle also. So this output is showing square wave output, because your input was DC and it is chopped like this. So DC signal plus 30 volt is given for S1 and S2 through the load, from what we can say, from left to right side through the load, correct? That means clockwise direction. So positive signal. Okay, yes. And then after negative signal means again S3. Two other switches are operating, that is S3 and S4. Okay, so because of that, again what we can say, again minus 30 volt you will get here. So see the signal 1 2 3 1 2 3. So plus 30 minus 30. Likewise 30 volt DC is converted into plus 30 volt and minus 30 volts with chopping, positive half cycle, negative half cycle, and square wave output, like this. So this is the inverter operation. Okay. Now you can take the reading, very easily by changing this one knob. So this knob will change your frequency. See the CRO waveform now. See the CRO waveform. Only frequency is changing. See. So you can vary the frequency. You can vary the amplitude also. That means voltage also, by varying the second knob. See, you can vary it. Okay. Now it is less. Now the voltage is less. Okay. So likewise you can vary it. Okay. Likewise you can vary amplitude also, that means voltage, and you can vary the frequency, that means time. Correct? By using these two, this thing. And then you can take two set of readings, okay, along with the waveforms of power circuit, and then you may have the control circuit waveforms also. So how to check this control circuit waveform? You have to have separate two grounds. Power circuit ground is separate, whereas control circuit ground is separate. Correct? So how to take the reading now? Here this is the ground, and here this is the this one is the your positive. So you can see this. What is happening here? You can see here. See the signal. This is control signal. You can show this also. You can show this also circuit where it is connected and what is the waveform. Correct? So as you vary this, what is happening? Only time is varying. Correct? I am telling about the control signal now. The control signal how to generate, that I am telling you.
Yes.
Okay, so I can vary this by using this clock, okay, and this block that is related to the very small power supply is given, and you may have change in the signal. सांगतो मी जे हे चालू केलं हां, see here, now this is the ground, okay. Now coming to the this signal part, let us see this signal should be in between this, huh? So see the signal, that means pulses, okay. This is one pulse, okay, and exactly inverted pulse is given to next switch. Suppose S1, if one pulse is given, second pulse will be the inverted pulse which is given to S2 switch. That means suppose this is S1, okay, the second pulse will be negative pulse will be given here. So here reverse pulse is generated. One is positive pulse, one is negative pulse. Positive pulse will be given to S1, negative pulse will be given to S2, so that the circuit will complete. Means current will flow from DC, S1, load, and then S2 and then ground, like this. So these two. Then similarly for remaining two switches, this is the second pulse. Okay, you can see and observe here. Okay. This is there. Here also you can observe what is the change in the amplitude or something like that. Any change in the amplitude? You can see, no. You can see it here. You can change the frequency. So very minor change in the amplitude. So you can't observe in this thing, you have to amplify the signal. That means you have to increase this amplitude, and then you can see the change, whether it is happening or not. Something is coming. Very minor change is there in the signal. Okay, in case of amplitude. Okay, very minor change, only 0.2 division or something like this. Okay. And then after you can come here, you can have direct power circuit reading. Okay, power circuit reading will be here. काय झाले ऑन झाले हां नाही कसं केलं ते इकडे झालं. See this reading, where are the readings? See na, actually this is increase this, then only you can see. Okay, okay, you can observe this signal. Okay, you can observe the time signal. So you have to measure this only, that much. So now no need of telling all the readings to you, correct na? It is very simple. That one table will be frequency variation or time variation, and second table will be voltage variation. Likewise, you can have two different set of reading, and that you can take it. Is it okay? Yes. Thank you. झालं का?